In this next session, we're going to load up the traverse we did yesterday and develop it further into a full-scale subdivision set of calculations. So I'm going to go to coordinate geometry. I'm going to right-click on the job directory and look at 1 through 20. The job I saved yesterday, which has 14 points in it, which represents my traverse, is job 18. So file, load a job. Job 18, just want my points, and just to confirm everything, we will do a 210 minus, which is the point list, and there they are. Now just to give you a sense of where we're going, this is the representation graphically of those points we calculated yesterday, and this is what I want to end up with. This is my completed traverse with all my lots all plotted out and annotated with line tables where the labels wouldn't fit and curve tables where the curve information wouldn't fit. And this again was part of a DXF file that was exported out to VoloView Express, which you can see up here. Here's what I'm using to view this thing, and obviously you can bring this straight into AutoCAD, in which case you'll have full manipulation of all the entities here, and in AutoCAD, of course, you can plot it to scale. In this first set of calculations we're going to do in coordinate geometry, this is the information, and again, this is a page right out of the samples book that we're looking at, page 88, for those of you who might be looking for it. We're going to develop some new points. We're going to develop a center line through the big parcel, and develop the center line for a cul-de-sac, which we're going to develop a bunch of lots around, that kind of thing. And this is all documented on this page right here. So at this point, one thing I haven't done is turn my printer on, so I'm going to hit the 1- command to activate printing before I begin. And just for grins, I might redo that 210 minus 1 through 14 just to get a listing of points that I started with to go with the printer. At this point, I'm going to enter 10 minus to occupy a point. I'm going to occupy point 2. Don't care about the back site. First point for storage is going to be 14, which already exists, and it's going to tell me so in a minute. I'm going to set azimuths as my entry mode direction standard, because that's what this example, that's how it was done. The first thing I'm going to do is calculate a side shot, a single side shot, so I'm going to enter 31 minus, and I'm going to define a direction by using 2 other points from 2 to 4, a distance of 6.85 feet. And it says that point 14 is already occupied, and do I really want to pick a different point? In this case, if I enter -14, putting a minus in front of your point number is an override, so that means I want to stomp on that 5,000, 5,000, since I already have that at point 1, and it will do so and calculate point 14 with those coordinates. So I've calculated 14, I'm still sitting on 2, and now I'm going to do an intersection. So I'm going to enter 91 minus for the intersection routine. And I want to go in azimuth due north, a distance of 100.55. My other known point at the other end of the intersection is point 3. Azimuth is also unknown. I'm sorry, azimuth isn't straight north. The azimuth is unknown. That's what the 0 means. Sorry for that misspeak there. So in this case, in this intersection, I happen to know my 2 distances. First one is 100.55. This one is a flat 100. And it calculates 2 choices, because in this case of a distance-distance intersection, there are 2 possible points. And the one I want is the 49.99 one, which is the second one, so I put in 2 to approve the second choice. And it shows me that 15 Is that point, and I can roll along. Set 10 minus to occupy another point. This time I want to sit on point 1. I don't care about a back site. It's telling me 16 is going to be the next point stored, and that's fine. Storage point, as I said, was 16. It's looking for a direction now. I'm going to first tell it I'm going to calculate a side shot. And I am going to again define a direction from point 1 toward point 12. A distance of 11 feet. And that gets me point number 16. I'm still sitting on 1. I'm going to define a direction again from point 1 to point 12. This time a distance of 15.88 feet. To calculate point 17. Now at this point I am going to reset myself to occupy point number 6. And at this point I am going to go into the intersection routine. A direction I don't know, a distance of 444.76. Oops, 76. The other known point is 16. A direction I don't know, a distance of 604.64. Again, it gives me both solutions to the intersection, and it's my job to figure out which one of those is right. In this case, it is again going to be choice 2, the 4384 intersection. Next thing we're going to do is enter the 10 minus, which we do frequently with this program, just to go back and redefine where we are and what we want to do. I want to occupy point 3. Again, backside is not an issue at this point. This time we're going to start storing at point number 30. So I'm overriding my 19 and we're going out to 30. And we are going to define a direction from 3 towards point 16, a distance of 135 feet. And we're going to establish point 30. And then we're going to define another direction from 3, from 3 towards 16, but with a twist. 16.3 says add 270 degrees to that 3 to 16 direction. So we do that, and we want to go 135 feet. And that will calculate for us point number 31. We will now forget what we're doing, go back and occupy point 18. Don't care about a backside. Point 32 is fine. We're going to again define a direction from point 18 toward point 6, a distance of 150 feet, to create point 32. And continuing on, define direction again from 18 to 0.6 plus 270 degrees again, a distance of 150 feet, to establish point 33. Now we are going to do an offset calculation, 33 minus, and it wants to know what our offset distance is, and it's 160 feet. It's going to establish points left and right at 90 degrees from that back site, points 34 and 35, automatically. And lastly, we will again define direction from 32 toward 33, a distance of 155 feet, to establish point 35, and that will finish this section of the example. Little background information on page 113 of the manual is the 90-degree offset side shot routine documentation, which you can look over, which expands on how that actually works. In the next set of routines we're going to be using the 180 and 185 offsets from center line routine. And this is the diagram of what we're going to be doing to create that center line through that subdivision. I wanted you to see this diagram before I did the actual calculations. It would probably make it a lot more meaningful. So this is the picture we're working towards as we do that. So at this point I am going to enter 10 minus. I'm going to occupy point 35. I don't care about a back site. My next storage point is 36. It's asking me for a direction. I'm just going to go 180 minus to get into the intersection routine. Right offset distance is 25. Left offset distance is 25. Next point down the road that's already established is 32. So it's able to establish points 36 and 37. And now I'm going to enter 185 minus to get into the curve section. Now, the points numbers I'm going to enter here are defined in the diagram. If we go back to the drawing here, we're looking at a point here, and a point here that define the sort of the tangent center lines of the street, and then we're going to establish all the relevant points along the way from that information. So, back to benchmark. Point B is 32. Point C is 35. And point D is 31. And the big curve radius is 145 feet. And it proceeds to crank out all these points that we need to have and all the curve data for the inside, center, and outside curves. Looking at the example we're working toward here, we just, I believe, solved this part of the street intersection. Our next act will be to solve this part of the street intersection. So that's what we're going to do with this next set of calculations, which are pretty much a repeat of what you just saw. So we're going to select 10 minus here. Going to occupy point 31. And we're going to start storing points at point 48. That's fine. And 180 minus to begin the routine. Right and left offsets are still 25 feet. Next point down the way is point 30, which establishes 48 and 49. 185 minus to get into the curb area. Again, our B, C, and D points are 35, 31, and 30, and our big radius. And this time, the radius is going to be put in as a negative because of the way the curve swings. and that defines the swing distance, and we establish points up through 59 and all the curve data related to those curves. Next thing we're going to need to do here is establish this cul-de-sac, which is here, and the street intersection data, where these two streets come together. So the next calculations, you'll see the 165 minus, I believe, is the cul-de-sac routine, and the 172 minus is a two-way street intersection. So at this point, we will enter 165 minus to go into the cul. Storage point is indeed going to be 60 for the next point. Our point A is 33. Our point C is 34. Our offset distance, since this is a symmetrical cul, there is no offset distance. Our radius is 50. Our street width is 50. Our first little radius is 15 feet. And since this is symmetrical in its entirety, our other little radius is 15 feet. And though that allows us to establish all these points. The page in the manual that references the cul-de-sac solution is page 250. Here you can see the straight entry into cul-de-sac, center point known, and sometimes it could be with offset point known. But here's what the two diagrams look like, so that you can kind of establish all the things we did, the little radiuses and the big radius and all that sort of thing, and the street width. So these diagrams help you a lot getting through these routines. And as long as we're reviewing manual content, on page 260, you'll find the routine for the 172 minus routine, which is the two-way street intersection, which is what we're going to do next. So again, a little documentation to follow along with helps a lot. So we are going to, at the command, we're going to enter 172 minus. Storage point is 70, and that's fine. Point C is 33. Point A is 35. Point B is 34. Street width 1 is 50. Street width 2 happens to be 50. And the first radius is 15 feet. And radius 2 is 15 feet. And lo and behold, we've established all the points that we need to around that street intersection. And one other little command we have that sometimes nice people ask for, so we put it in. Sometimes they want to see the extremes. So this just shows the most north, the most south, the most east, and most west coordinate, and what point number they belong to if you're looking for that kind of information, just to establish your maximum size of plot or whatever. At this point, I'd like to get a little plot of what I've got calculated so far. So to do that, I'm going to establish a group. So we go 130 minus, which brings us into the group routine. We want to add a group, and I'll call this group, I'll call it 101, just to give it something. And we'll call it Section 1 of the subdivision. Section 1. It's going to consist of a closed polygon, and all I care about is point numbers. Now I'm going to not make you watch the painful act of me keying all these in. I'm going to discontinue the recording, put the points in, then turn it back on again, and we'll show you what all the entries look like. Okay, we've entered all the points that make up the left part of the lot, the part to the left of the road. And this is just a simple matter of looking at the point numbers. Every time you see an RP, it means we're headed out to a radius point of a curve. These points are going to appear on the drawing when we plot it out in a minute. And we just wanted you to basically see the data as I click through it, so you can see what we did here. So we're going to say OK. One little nuance I wanted to show you. All right, we saved that. That's going to the file. Now, if we come back in and edit this, and we look at it, you'll see at certain spots, points that are contiguously going up like that, it will group into one point dash point. And also you can enter them that way when you have points that happen to go sequentially together. So if you had a bunch of points that are all in a row, you can just kind of put in 65-70 and it would assume you wanted to go 65, 66, 67, 68, 69, 70, that kind of thing. So just something to speed up entry if you want to, and it cleans these up, the data format up that way as it works its way through it anyway. So that's okay. We're going to add a group, which is the stuff to the right of the road. We'll call that group 102, and call it section 2, and its points, it's actually a closed polygon 2, and its point numbers. Again, I'll do the same thing and show you the results in a second. In this section, it's a little easier. The sequence 16 to 49 to 56, through a curve to 53 to 52 to 44, through a curve to 41 to 40 to 36 to 18. So that section is a little less work. You can say OK to that, and we've established the two sections, and they are both active. So if we plot them, it'll plot them combined. And so I say OK here. And I proceed to enter 127 minus. And again, following the tradition, I accept the defaults and get down to here. And we see, give it some name, sub D basic layout. We'll do, I guess. And automatic labeling, inside, outside, yes, no. Okay, I'll accept that scale for what I'm doing. 1, 2, sure, sure. And okay. And if we're lucky, whoa, we get this, and it looks right. I love it when a plan comes together. So again, just to get a better view of this, we will go to black on white. So we can see everything. We have our curve tables, our line labels that wouldn't fit. And again, following the tradition of what this application does, I can zoom into given sections and look at things in whatever detail I need to do that. And clicking up here on Zoom Extents always brings me back to where I want to be, and I can just pop up somewhere else and do exactly the same thing. So again, what you're looking at here is in VoloView Express, which, as we mentioned several times before, doesn't plot to scale, but will print to a sheet of paper. And you must use AutoCAD or AutoCAD LT or some program that doesn't have to be AutoCAD. There are several others on the market that can read a DXF file, and this will come in and you can plot it to scale, and it'll work just fine. With that, we will zoom back out, give you one last look at what we have here. Now we're going to proceed to plow these lots into each side of this thing and go from there.